Good morning. Here we go. Take out your notes packet, make sure you have something to write with, and definitely want a calculator today. Our notes, which used to be 5.5 in our old textbook, we're going to use these same ideas to preload Module 8. So I'm calling this 8.02. So scribble that out in your notes, put that up here. We're not going to use any textbook pages yet for this particular section, and your assignment is going to be in your packet, okay? So today we're actually using a target instead of an essential question that basically says this: I can determine if figures are similar, I can use some scale factors, and find missing dimensions if you have similar figures. So there's a lot going on here, all right? Similar. Now, when things are similar, they kind of share some common qualities. You know, if we were defining the word, they'd be alike, maybe not exactly the same, but they certainly would share some properties. In math, here's how we tackle this. We basically are usually looking at some polygons, and we'll say, same shape, size might be different. They could be exactly the same. Size might be different. I'm going to just abbreviate that. Okie doke. All right, so usually we're talking about polygons or some kind of figure there. And I'm going to have you put this symbol in front of the word similar. You're going to see it in printed things a lot. It kind of looks like a sideways backwards S, kind of sort of. Technically, it's called tilde on your keyboard. As you look at it, it's way up past the Q, kind of kitty corner where this pinky is when it sets on home row. But it's way up there. And math-wise, we use this to stand for similar. Same shape, size might be different. Here are some things you need to know about similar shapes. So let's say if I have like baby rectangle and big rectangle, okay? That's what we're talking about. Size might be different. The big thing is that the sides are proportional. So if you have, and we have to make sure we're making sure the sides match up or are corresponding. So I'm going to say corresponding sides are proportional. Cool. Corresponding sides are proportional. Okie dokie. Let's see. I'm trying to think if there's anything else I want you to put on there. I think we're good. Ooh. And let's say this. The angles are congruent. And I should put in front of there corresponding again, so I guess I'm going to abbreviate that. Corresponding angles are congruent, meaning when you match up the angles from the baby one to the big one, they are going to be exactly the same measurement, okay? They're equal to each other. So now that I've used parts about congruent and talking about angles, we got to make sure we know what that means. Congruent angles mean angles that have the same degree measure. The same number, same value. 90-degree angle, 90-degree angle. Same degree measures. And put this symbol in front of the word congruent. It has an equal sign with that tilde on top. Here's why we do that. If you have an angle over here, 40 degrees, angle over here, 40 degrees. We don't say that the angles are equal. We can say 40 degrees equals 40 degrees, but we say like angle A over here and angle J over here. They're congruent because they have the same measurement. They're not the same exact angle. They're in different parts of space, but their measurement is the same. That to you at this stage might seem super nitpicky, but as we build in higher levels of math, that's when we really put that into play, okay? All right, scale factor. Scale factor is some kind of ratio, okay? And remember, ratio means you're comparing two numbers, okay? And we use this, it's used to enlarge or reduce. So in other words, to make bigger or make smaller. So I'm going to say enlarge, makes bigger, or reduce. And should we just say an object? I guess I'm going to say similar figures. Let's just keep it all tied in with this vocabulary. All right, you're going to hear these phrases a lot in vocab. Basically, today, what we're looking at is like mini versions and larger versions of objects, okay? And the sides, if they are similar, the sides are going to make a proportion, okay, from the baby one to the big one, and so on. So in words, you have all of this. Corresponding angles are congruent. Corresponding sides must have lengths that form equivalent ratios. That means they're proportional. So they go through this whole diagram and say this. Here's angle A up here, 43 degrees. That one matches up down here with angle E. Okay, so notice these aren't even in the same orientation. For me, my brain has trouble with that. I would probably take this triangle and spin it so all the parts match up. So I would have my 43-degree angle, that's E. I would have the right angle here, and then angle F down here, which was the 47 one, so that all of these parts match up. And then if I call this triangle A to B to C, then I call this E to F to G. And it matches up perfectly, okay? But this hypotenuse side will match up with this hypotenuse side. Now they're different lengths. This one's 60, this one's only 30, okay? So 60 to 30, 48 down here corresponds to this side, to the F to the G side, which was 24. And then the AC side, this 36 matches up with EG, which was 18. See, if I turn it, then I can visualize how things match up in the right position. So the first thing I'm going to ask you is, all right, so take a look. Here's 3 rectangles. Which 2 are similar? J, K, or L? So I'm asking you, is rectangle J, is that similar? I'm going to put a question mark there. Is that similar to rectangle K? I don't know. Check the math. Let's see. In J, I have this relationship. 10 is the long side, and 4 is the short side. Boom-de-boom. 5 to 2 with K. Are these guys equal to each other? Is 10 over 4 equal to 5 over 2? Check it. You can check it with cross products and test it and say 10 times 2, that's 20. 4 times 5, that's 20. Oh, yes, they are. If their sides are proportional, bingo. That gives you similar figures. You know, you could test it this way as well and say, I'm going to match up 10 to 5. 10 to 5. Does that equal 4 to 2? You could set it up this way, and these guys are the same as well. So, hey, hot diggity. So definitely J and K are. J is similar to K. And I suppose I should draw the little rectangle symbol. How about L over here? Let's do J and L and see, are those 2 the same? Well, J was 10 to 4 if I go long side to bottom, which means L would be 12 to 5. Are these guys equal? Test it with math. That's the way we can look at it. 10 times 5 is 50. 4 times 12 is 40. Oh, not equal. Nope. So L is not proportional to J, okay, or not similar. And because it's not similar to that one, but these guys are, then it's not similar there either. So just these 2 are the similar ones. Test these ones. Pause the video for a second and see if you can match up which ones are similar. Did you figure it out? 8 to 4. So if I take A, which is an 8 to 4 ratio from tall side to short side, and I look at B, which is 6 to 3, are these guys equal to each other? Are they equal? Yes, they are. You get 24 and 24. Or you could look at it this way. 8 over 4 is 2. 6 over 3 is 2. They're equal. So definitely A and B are similar. Rectangle A is similar to B. What about C? C had a ratio of large side 5 to short side 2. Is 8 over 4 equal to 5 over 2? You could probably see that in your eyes. 8 over 4 is 2. This is 2.5. Or test cross products. 16 versus 20. Not equal. That guy is not similar. Mathematically, that's how you can show it. There are so many ways to set these up to test it. You just show me some work to explain how you are testing it to prove to me whether yes, they're similar or no, they aren't. Let's take a look at this one. A picture 10 inches tall and 14 inches wide. I got to draw a picture. 10 inches tall, 14 inches wide. So 10 inches here, 14 here. Have you ever seen these two little, it looks like a quotation mark? It's a shortcut way to abbreviate inches. Okay, now we have to scale it down. We're going to shrink it, all right? So we got to figure out what scale factor, how are we going to make this shrink? We want it to be only 1.5 inches tall when we get this image on the web, but we don't want it super stretched out long. We want it to stay proportional. Otherwise, it's going to look weird. So we don't know what this one is. I'll just call it X. Okay, set up a proportion and solve. You could go 10 width to 14. I should say 10 high, 14 wide. That matches up. So short side to long side, short side to long side. 1.5 over X. Psst, you could also set it up this way if you wanted. You could say short side to short side. So going from big one to the baby one, 10 is to 1.5 as 14 is to X. You can set that up because your cross products, 10 times X, 10 times X, 1.5 times 14, 14 times 1, they're all going to be the same. I'm going to put this in parentheses. This gives you 21. This gives you 10 times X, and when you divide by 10, you should get 2 1/10 inches. Psst, that doesn't really make sense because we don't measure inches and tenths. It's always halves, quarters, eighths, 16ths, 32nds and stuff, but we'll let it go. Ooh, toy replica of a tree is 9 inches tall. Okay, so you've got like the toy tree, blah. Don't make fun of me. And then you have the big tree, okay, that's way bigger. Now, it's going to be hard to get that drawing to look very scale-like. So for me, instead, I would probably just think of this proportionally and then tell myself, all right, I'm going to match up the height of the tree, tall, versus the branch. Okay, so I'm going to go tall over the measurement of the branch. So my toy is 9 inches tall. The branch, that's what I'm trying to find out. That has to equal the actual tree's height, which they say is 6 feet, over a branch that's 60 inches. Now hang on here. If this is in feet, then I should keep this number in feet or change everything to inches. Okay? I'm going to tell you, you can do it both ways, and I'm going to show you both ways. 9 inches to how many inches for the branch. I'm going to leave this, I'm going to turn 6 feet into 72 inches. 60 inches, if you take 60 and divide by 12, you get 5 feet. Now, I'm doing it parallel each way so you can see, even by leaving it as feet, if I just turn 60 inches into feet, this is going to work. Sounds weird. 9 inches times 5 feet. That just do the numbers. 9 times 5 is 45. X times 6. Okay, because I have inches times feet. This is going to be inches times feet. It's going to work out as weird as it seems. Divide by 6, divide by 6. You should get a value that looks like this, 7.5 inches. Try it this way. This might make more sense. 9 times 60 equals X times 72. Divide both sides by 72. And you get this, 540 divided by 72 equals X, and you get 7.5 inches. Bingo. It works. So cool. This particular module, there's going to be so many different ways that you can solve it, which is so cool. I want you to pick a way that makes the most sense for you. A flag in the shape of an isosceles triangle. Do you remember what that means? Great word. Isosceles triangle is a triangle that has two of its sides equal. Okay? Phew, that almost looks equilateral. Yikes. I should make this. I better redo my drawing. I'm not the best at drawing. Darn. All right, let's try this again. All right. Boom, boom, boom. Ugh. Sorry. This is just not good. This is the long side, 24. Imagine this like flying on the flagpole like this. Here's your flag. Each of these sides is 18 feet, 18 feet, 18, 24. Okay? You are going to put that same logo on a t-shirt. So we're going to make a tiny version that looks like this. We want it to be exactly similar and proportional. They want the even sides to be 4 inches. 4 inches, so we don't know that side. What is the length that this one has to be? Gosh, there's so many ways to think of it. If you want to think of it as figuring out what is the relationship between these two sides, like 24 and 18, you can set up a proportion that way. What's 24 to 18? Long side to one of the evens. 24 feet to 18 feet. That would have to match up. Okay, this is your x. This corresponds to this one. X over 4. And these are in inches. Okay? So really, if you're thinking about it, you're saying 24 times 4 divided by 18, cross product wise. If you're focused on always figuring out what's this ratio when I divide, it's okay. 24 times 4, 18 times x. Let me show you something. Cross products are equal. And then when you divide both sides to isolate x, take a look what happens here. You find this ratio, 24 divided by 18, and then multiply by 4 is really all you are doing. So go ahead, grab your handy dandy calculator, and let's see what you come up with there. This one is not so lovely when you crank it out. And if you're grabbing your calculator, when I do this by hand, I'm saying common factor of 6, 3. Common factor of 6, 4. So I get 4 times 4, which is 16, divided by 3, which is 5 1/3, which is on your calculator, if you get 5.3 repeating, this should be inches. So if you write it this way, make sure you put the repeating bar because I didn't say round it, okay? But there's your answer. Cool. Flip your paper over. Let's look at a couple more. A rectangular house is 32 feet wide and 68 feet long. I got to draw a picture. All right, 32 feet and 68 feet. On a blueprint is like a drawing of it. On the blueprint, here's what happens. Clearly, we're not going to have the same exact size. It says that the width is 8 inches. So this is like the baby version, teeny tiny. The width is 8 inches. And the length is, I don't know. So you can set this up, 32 to 68. If you went width to length. And then here I'd go width 8 inches. I should say feet to feet, as inches is to inches. This is a big old X. Okay? Cross multiply, find your answer. Or maybe you set it up another way. 68 times 8. Divide both sides by 32. Divide by 32. Boom chakalaka. Solve and find your answer. And I believe on this one, let me just check. Oh, this did work out nicely. I think you get exactly 17, don't you? 4, yep. So you should get 17 inches. Now, that's just one way to do it. I said width to length equals this to this. But you could say 32 feet matches up with 8 inches on the drawing. You could set it up this way. 32 feet, this width, match that up with this width, 8 inches. That has to equal the ratio of the length to the length, which would be 68 feet to, I don't know, no, 68 feet to x. Okay, and this is in inches, feet to inches, feet to inches. This will also work because you get 32 times x, 8 times 68, 68 times, yep, you'll get the same answer. So many ways to set it up. Yes, just match up the corresponding parts. Last one. Karen enlarged a 3-inch wide by 5-inch tall photo. Okay, so here's the picture. It's 3 inches by 5 inches. Okay, the poster is going to become ginormous. Okay, and it has to be proportional. It is 2.25, or in other words, 2¼ feet wide. How many feet tall is it? So this is, I don't know. You can set up a proportion any way you want, as long as you're using corresponding parts of your image. So if we say 5 inches tall to 3 inches wide, I'm thinking tall to wide, tall to wide. So then x feet tall as 2.25 feet wide. Inches, inches, feet, feet. Or you could set it up this way. I want to match up little side, or I'm sorry, tall side to tall side. You could say 5/x equals 3, which matches up with this one, 3/2.25. Oh my gosh, you could do it either way. You will come up with the same answer. Go ahead and use your cross products to solve. Notice I was slacking here and I didn't say inches to feet, inches to feet. So that way you know what your labels are, but it's all going to work out. Okay. When you do your cross product and divide on this guy, you should end up with the missing side, which is how tall the poster is going to be, of 3 3/4 feet. Ta-da! There you go. Oh my gosh, so many options. This gets me so excited because there's so many different ways to tackle the same problem. You get a lot of choices. Very, very cool. All right, your assignment's posted in Schoology, so good luck and may the force be with you.